Welcome back. This is 2.4 Journal. We are learning how to simplify factors. So today, your I will statement, I will be able to simplify factors in fraction multiplication. All right. So some vocabulary that we've already talked about in previous lessons. We're going to talk about fractions, numerators, denominators, equivalent fractions, improper fractions, mixed numbers, cross-canceling. That one's going to be new. We're going to add that to our vocabulary page in just a minute. So if you want to also have, besides page 32, if you want to pull out page 27, that will be helpful. Okay, and factors. All right, so here it says, multiply the following fractions like we did in the last lesson. Multiply the numerators, meaning the top numbers. Multiply the denominators. And then simplify your product. All right, so we have 24 times 15. So I'm going to do 24 times 15 to save us time on the video. I'm just going to do this by calculator, but usually you would have to do this by hand. So 24 times 15 gives me 360. Multiplying 35 times 16 on the calculator, just to speed it up, is 560. All right, now we've got these large numbers. We're going to simplify it if we can't. In 0. I can divide this by 10. And I can divide this by 10. So 360 divided by 10 gives us 36. Divide 560 by 10, we get 56. All right, what's something that goes into both 36 and 56? They're both even, so I'm going to divide by 2. 36 divided by 2 gives me 18. And 56 divided by 2 gives me 28. Divide by 2. 18 divided by 2 is 9. And 28 divided by 2 is 14. Okay, there's nothing that goes into both 9 and 14, so that's as simplified as it can get. All right, so that way works. But you see how large these numbers are? I'm glad they ended in a 0 so I could divide by 10 and make them much smaller, much quicker. But that could have been really ugly to try and simplify. Okay, we're going to try the same problem, only this time we are going to simplify the factors. Remember that factors are something that divide into both. So like 2 was a common factor of 18 and 28, so I divided them both out to get 9 and 14. So we're going to simplify the factors across from each other, or this is also what we call cross-canceling. Before we multiply. All right, cross-canceling. Pull out the vocabulary sheet for chapter 2, and we're going to write about cross-canceling. So, when cross-canceling, this only works when multiplying fractions. So you can't do it with anything else. It only works with multiplying fractions. So, when multiplying fractions, this method simplifies fractions before multiplying. By canceling out common factors. But the key is they have to be across from each other. So it has to be something on top and something on bottom. You're not canceling across, you're canceling on top and on bottom. So I want you to write that here, on top and on bottom. So I can't cross cancel 12 and 15. Yes, 3 goes into both of them, but I can't cross cancel them. It has to be across the division line. But it can be here or it can be here. So what I like to do is I like to look across from each other. Remember, you can only do it when there's a time symbol in here. So 12 and 28. I want to simplify it first. So I know that 4 goes into both 12 and 28. So 12 divided by 4, we cross it out. And we simplify it. We say that's 3. Now I have to do it somewhere on the bottom, or else it doesn't work. So I have to cancel out 4 up here and 4 down here. So 4 goes into 28 7 times. So all I've done is divide by 4. Now I look this way and I see that both of them end in 5. So that tells me that 5 goes into 15. 5 will go into 15 3 times. I divide the bottom over here by 5. That gives me 7. Now don't get fooled and think that you can cancel across from each other. You can only do it. Now that I have nothing else top to bottom, I can multiply across the top. And then I get 3 times 3, which is 9. And 7 times 7, which is 49. But now, because I cross-canceled at the beginning, I have no factors in common, so that means my answer is already simplified. Now the reason I like this better is because it makes it so I'm only working with smaller numbers instead of large numbers like we got when we multiplied over here. 360 and 560 are huge. Luckily they were too hard to simplify from, but if you end up with some really large number, then you're like, I don't know where to start. It's a lot easier to think with numbers like 24, 16, 15, and 35. So we're going to look across from each other, top to bottom. So 24 and 16, do they share anything in common? Both can be divided by 4, so I'm going to divide 16 by 4 and rewrite this as 4, because 4 times 4 is 16. I'm going to divide 24 by 4, and that would be 6. 15 and 35 both divide by 5, so if I divide that by 5, I get 3. If I divide this by 5, I get 7. Okay, sometimes you can cross cancel again. See how I have 4 and 6? That means 2 can go into them again, so I'm going to divide 4 by 2 and get 2. I'm going to divide 6 by 2 and get 3. Okay, now top to bottom, even above each other, you can do that too, as long as it's a top to a bottom. 3 and 7 share nothing in common, 3 and 2 share nothing in common, 3 and 7, 3 and 2. So I'm done with the cross canceling. Now I just multiply across the top. So 3 times 3 is going to give me 9. And 7 times 2 gives me 14. Look, that's what we got up here after all this simplification. The reason cross-canceling is so nice is because you can simplify it and make it a lot easier to work with to begin with. Now remember, this only works on multiplying. Alright, so why does this method work? Since we multiply the tops and the bottoms together, so we multiply the tops together, that's how I should probably say it, and the bottoms together. So since we're multiplying them, we can divide both by the same number to simplify. We can divide those numbers out first and then multiply. And it works because multiplying and dividing are just inverse operations. Okay, let's try simplifying factors before we multiply these examples. Okay, estimate first. So if I'm estimating here, 4 over 5, that's almost 5 out of 5, so that's about 1, times 10 over 22, that's about half. So we just use benchmark fractions that are easy to work with. 0, half, and 1 are probably good enough. So 1 times 1/2, my answer is going to be near 1/2 when I'm done. That's all the estimation is. It's to give me an idea if I did something right or if I'm off. Alright, so if I can simplify across from a top to a bottom, I will. I could even do it here. So see how 10 and 22, a top to a bottom, I know that 2 goes into 10. I'm going to write a 5 here because 2 times 5 is 10. 2 can go into 22 11 times. Okay, as long as I can go top to a bottom, it'll work. 4 and 11 share nothing in common. 4 and 5 share nothing in common, but 5 and 5 share a 5 in common. So I'm going to cross cancel out. 5, divide this by 5, I get 1. Divide this by 5, I get 1. So I multiply across the top. 4 times 1 is 4. 1 times 11 is 11. This is close to 1/2. So my estimation tells me that I'm in the ballpark. Alright, let's estimate this one. 2/3. That could be, that's pretty close to 1/2. 9 out of 35. Let's see, 9 out of 36 would, if I reduce that, that would be about 1/4. And 7 over, that's about 1/2. So if I'm going to times those, 1 times 1 times 1 is 1. 2 times 4 is 8. 8 times 2 is 16. Ooh, 1/16. In other words, this is going to be a really small fraction when we're done. Okay, so there's our estimating. Now let's cross cancel to help us make this easier to begin with. If I were to multiply 2 times 9 times 7, I'm going to get a really large number. But if I can cancel something out, that will help me out. So 2, I look to something in the bottom. 2 and 3 share nothing in common. 2 and 35 share nothing in common. As long as it's all multiplication, you can check with every denominator with this numerator to see if it works. 2 and 12 do share something in common. So I'm going to divide by 2. 12 divided by 2 is 6. 2 divided by 2 is 1. Alright, now 9. 9 does not share anything in common with 35, but 9 does share something in common with 3. So I'm going to do 9 divided by 3, which is 3, and 3 divided by 3, which is 1. Okay, 3 and 6 share something in common, so 6 divided by 3 is 2. 3 divided by 3 is 1. Okay, up here, 7 and 35 share something in common, so 7 divided by 7 is 1, and 35 divided by 7 is 5. Okay, multiply across the top. 1 times 1 times 1. That's way easier than multiplying 2 times 9 times 7, then reducing it all afterwards. Across the bottom, we have 1 times 5 times 2, which is going to give me 10. So my estimation was about 1/16. 1/10 is small, close to 0 fraction. So that was a good estimate. So by doing that, we can see that when multiplying fractions, cross-canceling can be a wonderful skill to have. Now we're going to apply this to mixed numbers. So I want you to remember this. When multiplying mixed numbers, meaning whole numbers and fractions, remember that they are only good for final answers. We only like mixed numbers for final answers. So turn all mixed numbers into improper fractions. And you saw how we did this yesterday in the modeling. Before multiplying. To do this, we multiply the whole number by the denominator, then add that number to the numerator. Alright, so we have some lovely mixed numbers here. They're only good for final answer, so I want to turn all of them into improper fractions. So, I like to imagine cakes. If I have one whole cake and 3/4 of another cake, I want to chop all the cakes into fourths and see how many pieces I have. So that's why I times 1 times 4, because I get 4 pieces from the whole cake, and add it to the 3 I already have. So 1 times 4 is 4, plus the 3 pieces I already have. That would be the same as 7/4. Okay, now let's turn into an improper fraction. So if I have 2 cakes, each one's chopped into 14 pieces. 2 times 14 gives me 28. 28 plus the 3 pieces I already had would be 31. So I have 31 over 14. Okay, now I'm to here. Now we just multiply like we've been doing. Simplify factors if we can. So 31 does not share anything in common with 4. 31 does not share anything in common with 14 either. 7 does not share anything in common with 4, but it does share something in common with 14. 7 goes into both, so I'm going to divide 14 by 7 and get 2. Divide 7 by 7 and get 1. I have nothing else in common, so I'm going to multiply across the top. 1 times 31 gives me 31. 4 times 2 is 8. So now I have an improper fraction. Now I want to turn this into a mixed number because I'm going to have a final answer. So 8 goes into 31. 8, 16, 24, 32. 32 is too much, so that means 3 times. Those of you that don't remember, so we're really doing 31 divided by 8. 8 goes into 31 3 times. I'm going to use, and then I'm going to subtract that and see what I have left. 11 minus 4 is 7. 2 minus 2 is 0. So I get 3 and 7 pieces left over out of 8. So 3 whole units and 7 eighths. Now because I cross-canceled back here, all I had to do is turn that into a mixed number. I don't have to cancel anything out here. 7 eighths is as simplified as it can get. Alright, let's do this one. Turn this into an improper fraction. 3 times 3, so 3 whole cakes cut into 3 pieces each is going to give me 9 pieces. Plus the 2 pieces we already had, that would be 11 over 3. Now 9 is a whole number. We still want to make it an improper fraction. But the way to remember this, since we have whole units, that means there is 1 piece for every whole unit. So we're just going to write 9 over 1. Alright, cross cancel if we can. 11 does not cross cancel with 3 or with 1. But 9 and 3 share a common factor. So I'm going to divide this by 3 and get 1. Divide this by 3 and get 3. Multiply across the top. 3 over 1 times 1 is 1. And 33 over 1 is the same as 33 complete pieces. So what this is saying is if you had 3 and 2/3 cakes and you had 9 of those orders, you would have a total of 33 cakes when you were done. Okay? Alright, rate yourself on this concept. 0, I don't get it at all. 1, I do a little, but I need some help. 2, 3, 4, meaning I got this and I could teach somebody else. Circle it, take a picture, and put it in your math journal.